Hi guys, welcome back to In Case of Econ Struggles. Welcome to another AP Micro Struggle. Today we're covering topics 2.3 to 2.5, which are all talking about elasticities. Here's what the College Board wants you to know about elasticities. We're going to talk about elasticities conceptually. When you get that elasticity number, we'll talk about what it means in terms of being elastic, unit elastic, or inelastic. Then we're going to talk about specific elasticity, so we'll talk about the price elasticity of demand and supply. We'll talk about the income elasticity of demand, and finally we'll talk about the cross-price elasticity of demand. So timestamps are below if you would like to jump around, but let's get right into it. Here's the basic idea with elasticities. The basic idea with elasticities is we're trying to measure responsiveness. So what's going to happen is we're going to change one variable by a little bit. We'll call that variable x. And we're going to measure how much another variable y changes in response to that change in x. So normally this is in percentage terms. Just to give you a real-world example, let's say that we think that the chance of it raining today goes up 5% every time the temperature drops by 1%. That's the relationship between temperature and rainfall probability. We would say that the temperature elasticity of rainfall probability is 5%, or the percent change in rain over the percent change in temp is equal to 5 over 1, or 5%. So notice that here our rainfall probability is going to be our y, and our temperature is going to be our x. So it's always the x elasticity of y is whatever this number is. Now when we do this fraction, of course you're going to get a number. That number is going to range from negative infinity to positive infinity. Just to make it a little easier to interpret for this number line, let's talk about absolute value just to make it a little easier. So if we start from 0, 0 means that y does not respond at all to x. So if we think back to that rainfall example, that would mean that no matter what the temperature outside is, the chance of rain doesn't change at all. We would call that perfectly inelastic or non-responsive. Now, as you go from 0 to 1, as long as you're less than 1, that's inelastic. We're not perfectly inelastic, we're just inelastic. When we get to 1, that's what we call unit elastic. Why do we call that unit elastic? We call that unit elastic because that's a 1-to-1 change in y to x. So that would be something like for every percent the temperature goes down, the chance of rainfall also goes up by 1. The absolute value of that is 1 over 1, which is just 1, and we call that unit elastic. As we get more than 1, we become elastic. What does it mean to be elastic? That means that y is changing more than the change in x. We calculated that temperature elasticity of rainfall probability at 5, which is more than 1. Because the rainfall probability changes more than the corresponding change in x, or the change in temperature. Temperature only changed by 1%, but rainfall probability changed by 5%, so that is more than 1, so that is elastic. Perfectly elastic would be like if we got 1,000,000, so that would be a super, super big change in y with a tiny change in x. Now that we sort of know what's happening with elasticities, let's get into our first actual elasticity, which is the price elasticity of demand. Using that example with rainfall that we just talked about, you can see that price is going to be our x variable and quantity demanded or demand is going to be our y variable. So how we would translate this into English is to say how responsive is quantity demanded to a change in price. So what we're going to do, unsurprisingly, is that formula is going to be the percentage change in quantity demanded over the percentage change in price. We also just talked about demand, specifically the law of demand, which says that as the price goes up, the quantity demanded goes down. So we would expect this elasticity to be negative because quantity demanded is falling as price is going up. So these have different signs, and we're going to get a negative number. And just to tie that into that number line we just saw, if our price elasticity is between negative infinity and negative 1, we're going to be elastic because, again, if we think about absolute value, this is 1 to infinity. But with the actual sign, it's negative infinity to negative 1. Still means that we have elastic demand. If we have negative 1, it's going to be unit elastic. And if our elasticity falls somewhere between negative 1 and 0, we're going to be inelastic. Again, if we fall exactly at 0, we are perfectly inelastic. I think numbers can be kind of hard to visualize, so here's just a couple demand curves that I drew just to give you a sense of what some of this might look like in terms of elasticities. Notice that elasticity is not equal to the slope of the demand curve. Nonetheless, I can draw a couple useful examples. Here's a perfectly inelastic demand. You can see that when price changes, quantity doesn't change at all. Here's a perfectly elastic demand curve, and you can see when the price changes just a little bit, the quantity instantly falls to 0. And then I've just drawn something like an inelastic demand curve versus something like more elastic of a demand curve. Again, this is just to give you a picture of some of those numbers that we saw earlier. Price elasticity of supply or quantity supplied, very similar to the price elasticity of quantity demanded that we just saw. The only difference is that this is going to be a positive number. Why is this a positive number? Well, if you remember from our last video, we talked about Deb's donuts. Deb wanted to produce more donuts the higher the price she was being paid for each donut. So if the price goes up, we would expect the quantity supplied to also go up, which means that both of these guys in the numerator and the denominator have the same sign. And if they have the same sign, we're going to get a positive number for elasticity. And then here again are the interpretations of the number you get, where 0 to 1 is inelastic, 1 to infinity is elastic, and 1, exactly 1, is unit elastic. Once again, putting some pictures to these numbers. Here's a perfectly inelastic supply curve and a perfectly elastic supply curve. Looks very similar to those perfectly inelastic and perfectly elastic demand curve. It's not an accident. Again, this perfectly inelastic, for example, means that the quantity doesn't change even when the price changes. So notice I've just drawn an inelastic and an elastic supply curve. Again, we're just trying to get a better sense of what's happening. Now we're going to move off prices and talk about something called the income elasticity of quantity demanded, or the income elasticity of demand. And this is not about a change in price. This is how responsive quantity demanded is to changes in your income. So we talked in the utility maximization problem about how much money you have in your wallet. And this elasticity is asking, if I give you more money in your wallet, how does quantity demanded of a certain good go up or down? And here's how I want you to think about this. Let's say that you're in a grocery store and that grocery store serves two things. They're going to serve cheap ramen, like that 99-cent ramen stuff. They're also going to serve a really nice ice cream, maybe made by two people in upstate Vermont. And what you're trying to think about is how the income elasticity of quantity demanded looks for both of those goods. Well, for the cheap ramen, unsurprisingly, as you have more money in your wallet, you're probably going to buy less of the ramen. So we would say that the income elasticity of demand for ramen is probably negative. So we would call ramen a inferior good. Because as you get more money, you're like, I don't really need more of this ramen in my life. I can buy other things that cost more, but I like more. On the other hand, for that nice ice cream made by two guys in Vermont, you might say that as I get more money in my wallet, I'm going to buy more of those pints of ice cream. So we would call those pints of ice cream a normal good, because as you get more money, you buy more of them. So the income elasticity of quantity demanded for that good would be positive. You might have a special case where you get something really, really close or equal to 0. If you get an income elasticity of quantity demanded exactly equal to 0, they're neither normal goods nor inferior goods. They're just goods. The last elasticity we're going to talk about is the most complicated, and this is the cross-price elasticity of demand, or quantity demanded. So this is how responsive the quantity demanded of good A is to changes in price in good B. So once again, we're going to set up a very simple grocery store with two goods. In the first grocery store, I'm going to have two goods. It's going to be peanut butter and jelly. And let's say that the price of peanut butter goes up. If the price of peanut butter goes up, the number of peanut butter and jelly sandwiches that people make is probably going to go down. So since peanut butter and jelly are frequently bought together, it's probably going to be the case that quantity demanded of jelly also goes down, even though the price of jelly hasn't changed. The price of peanut butter has gone up. Peanut butter and jelly are complements. They go together well. So if you're buying less peanut butter, you're probably also buying less jelly. So your cross-price elasticity of jelly, where the price you're looking at is the price of peanut butter, is probably going to be negative, because the price of peanut butter goes up, the quantity of jelly goes down. Now, in a different grocery store, you have two different goods. It's going to be Coke and Pepsi. The price of Coke goes up. Well, Coke and Pepsi are probably substitutes for a lot of people. So if the price of Coke goes up, then people are going to switch away from Coke and buy more Pepsi. So as the price of Coke goes up, the quantity demanded of Pepsi also goes up, so your cross-price elasticity is positive. Those are just two examples to show that if your cross-price elasticity is negative, the two goods are complements, and if the cross-price elasticity is positive, they are substitutes. If it's really close to 0, those two goods are just two goods. They're not related to each other in any way. Hopefully this gives you a better understanding of exactly what an elasticity is and some common elasticities you need to know. If this was helpful, make sure to like and subscribe, and we will see you next time for another case of econ struggles.